Okay, guys, so we are now going to graph parabolas using 3 easy steps. So last week we graphed parabolas using a table, and now we're going to graph parabolas using 3 easy steps, and the steps are shown here. So I'm going to go through each one with you one at a time, okay? So we know that what the vertex is of a parabola, okay, it's the maximum or minimum point. So I need you to visualize that. It's the maximum or minimum point of the parabola. And the way that we find the parabola is by doing these 2 steps, okay? So you know that each point on the coordinate plane has an ordered pair of x and y. Okay, so we have to find the x and y, okay, of the vertex. And the way that we find the point where that parabola begins, the vertex, the highest or lowest point of the parabola, is by doing these 2 steps. Step 1 is we have to find the x value, and then step 2, we're going to use that x value to solve for the y value, okay? So how do we find the x value? Just by looking at this quadratic right here. You're going to have to, it's a little formula you're going to have to memorize, even though I don't like memorization. It's just something that you're going to have to remember. To find the x value of the vertex, okay, that highest or lowest point of the parabola, to find the x value, you have to use this formula, x equals negative b over 2a. Well, where am I getting the negative b, over 2a? Remember, this is why I had you write the standard form of the quadratic over the quadratic that we are graphing, because this is our a term, this is our b term, and this is our c term, okay? So this is where we get our a, b, and c, okay? So, guys, to find the x value, okay, we're going to use this formula. So just like I've always done in the past, you write the formula and then you rewrite it with the empties. So let's do it. You're going to write negative empty, okay, over 2 times empty, and then you just fill in those empties and do the math, okay? Not too difficult. So what is our b term in our quadratic that we are graphing? Negative 6. So everyone put negative 6 in that little spot, okay? And then what is our a term, guys? Okay, remember, it's our a term, b term, and c term. So look at the quadratic we're graphing here. What is the a term? Okay, so even though it's not there, okay, when I ask you for the a, b, or c term, I'm asking for the number. So even though it's not there, you know there's a 1 there. Okay, so 1 would go in the denominator. And just simplify, you guys. This is super easy. So what is the opposite of a negative 6? Positive 6, and 2 times 1 is 2, and simplify, you get 3. So the x value of our vertex is a positive 3. Does anyone have any questions as to how we got the x value of our vertex? Because we're gonna use that now to solve for y. So look at part B of step 1. Now you plug in that x value to solve for y. Well, where are we going to plug it in? See, y is equal to whatever the result of this is, you guys. Okay, so everyone write y equals empty squared minus 6 times empty plus 4. Okay? Why did I create those empties? Because we just determined that the x value of the vertex is 3. Okay? So that's what's going to go in. Y is equal to whatever the result of this is. Okay? So we're going to put 3 here and 3 here and do the math. Okay? So y is equal to, so 3 squared is 9. Negative 6 times 3 is a negative 18 plus 4. So y equals 9 minus 18 is negative 9. Negative 9 plus 4 is a negative 5. Okay, so that's how we put and then we put our y value up here. So now we know that our vertex of this parabola is at a positive 3, negative 5, okay? So, and we're going to use that same process for the next 2 points that we're going to choose, okay? We're going to choose the x values, and then you just plug in your x values to get your y values, okay? It's the same process for the next 2 points. But anyway, I'm going to erase this, okay? And I'm going to leave that right there, okay, because we're going to use the same process. You just have to do it 3 times. So guys, our vertex is a positive 3, negative 5. So everyone go to positive 1, 2, 3, negative 1, 2, 3, 4, 5, and put your dot, okay? So that's the vertex. And by the way, are we going to wind up with a smiley face or a frowny face? Smiley face, because the a value is positive, okay? So we know that this is our minimum, right? Because that's the vertex, and it's only going to go up from there, okay? So now you're going to pick 2 points. Well, guys, I'm going to tell you every single time to pick the easiest 2 points possible, okay? And since we know we have to plug in these x values, okay, into our quadratic to figure out what y is equal to, always choose the easiest x values you can think of, which is 0 and a positive 1. So watch this, you guys. If I put 0 here and 0 here, okay, we're going to figure out mental math what our y value is going to be equal to. So 0 squared is 0, and negative 6 times 0 is 0, and 0 plus 4 is 4. So we've got our first point is 0, positive 4. So let's plant it, okay? So 0, positive 4. 1, 2, 3, 4. Okay? And now we're going to choose the x value 1, okay? So again, using the same process. So we know what our x value is because we're just choosing the easiest x values possible. We're plugging it in to the same quadratic, obviously, and doing the math. So guys, 1 squared is 1. Negative 6 times 1 is negative 6 plus 4. So just, do the math. 1 minus 6 is negative 5. Negative 5 plus 4 is negative 1. Okay, so we have negative 1. So now let's plot this point on the coordinate plane as well. Once you figure out what these 2 points are, you put them on the graph. So we have positive 1, negative 1. So positive 1, negative 1. Okay, so we've got 3 points on the line. Okay, now guys, let me erase this part. Okay, so you can see the graph. Okay. And then step 3 is use the axis of symmetry and connect the dots. So everyone at this point, I want you to just draw a dotted line through the vertex, which is also your axis of symmetry. So who can tell me what is the equation of this axis of symmetry? 3. Right, x equals 3. That's the equation of that axis of symmetry. Now let me show you how you're going to use the axis of symmetry to plot the other 2 points that we need to complete the graphing, okay? So watch this. So here we are at the axis of symmetry, you guys, and this point is 1, 2, 3 spaces to the left. Well, since the axis of symmetry is an identical mirror match, you're going to go 1, 2, 3 and plot the point to mirror image the point here, okay? Now look here from the axis of symmetry, we go to 2 spaces to the left to get to this point. Well, same thing, you're going to do 2 spaces to the right and plot your dot, okay? And then we're going to just connect the dots. And now you're able to answer a bunch of questions, right? this has a positive A value because it's a smiley face. Is this a maximum or a minimum? Minimum. And there's one thing that I need to also add to this. Everybody write y-intercept. Okay, everyone write y-intercept. Okay, guys, the y-intercept for a parabola is the same thing as the y-intercept for a line. So the y-intercept is where does this parabola cross over the y-axis? It's right here, guys. See that? So you have our y-intercept is 0, +4. Okay? And so let's talk about our domain and range. So guys, what is the domain?
The domain is real numbers.
All real numbers. And what is the range?
Range is range of.
Well, the range, y, where does this parabola begin? At a -1, 2, 3, 4, 5. So y is greater than or equal to -5 because it starts at -5 and it goes up from there. Let me see if there's anything else I forgot to mention. Y-intercept, domain and range, axis of symmetry. It's positive. It's a minimum. That's all I can think of for now. So that's how you graph a parabola with those three easy steps.